Dear students, welcome back. The next topic is about measurement. And here we focus on the measurement of length. The word measurement can be used in many places, but here we are only interested in length. Measurement means you are given a value for something. For example, if you want to buy a pipe for your house, when you go to your shop, you must be able to tell the shopkeeper how much length of the pipe you need. Today, we have a system called the International System of Units, SI units. Here we use meter to measure the length. So you can say, I want a 3-meter pipe or a 4-meter pipe, and people can understand and they can measure and give you the pipe. But think about it 1000 years ago, where there are no meter then. So people used many other ways. For example, they used a hand span, but one person's hand is bigger, another person's hand is smaller. So it was not the same everywhere. Maybe in one place it worked because everyone knew the same person's hand. But when kingdom grows bigger, it was difficult. So people started using a common object. For example, a stick of a fixed length. That stick could be copied and carried everywhere. This worked as long as the length was not very critical. But when the science grew, people wanted a reliable and exact way. So the international system defined 1 meter. Now, wherever you go in the world, 1 meter is always the same. Still, we can't use only meter for everywhere. For example, a baseball bat can be about 1 meter. But what about small things like a pencil or an eraser or sharpener, etc.? We can't use meter for measuring them also. So we divide 1 meter into 100 parts. Each part is called a centimeter. Each part is called a centimeter. Now in this case, you can say this pencil is 17 centimeter long. cm stands for centimeter. And this pencil you can say as 8 centimeter long. So as the pencil is smaller, I cannot use meter. So I am using something called centimeter, which is cut by 100 times. 1 meter is cut by 100 times. You get 1 centimeter. Now let us see another case of pencil tip. This tip is smaller than centimeter. So we divide 1 centimeter into further 10 parts. You can see here, I have divided 1 centimeter into 10 equal parts. One small part is called 1 millimeter. That means 1 centimeter is cut into 10 parts is equal to 1 millimeter. So you can say this is 1 millimeter or half millimeter or 0.7 millimeter tips. That means it is so small I cannot use meter, I cannot use centimeter, I have to use millimeter. If you want to measure something even smaller like a hair, I want to measure the diameter of this hair, meter cannot be used, centimeter cannot be used, and even millimeter cannot be used. These are all very big for the diameter of the hair. You can see here. Now what I do, I take 1 millimeter, divide them into 1000 small pieces. So if I cut 1 millimeter into 1000 small pieces, I get 1 micrometer. This is a symbol called micro. This is called 1 micrometer. So I take 1 millimeter, which is so small because I divide 1 centimeter into 10 pieces. I get 1 millimeter. And I take this 1 millimeter, cut it into 1000 pieces. I get 1 micrometer. So the hair, human hair, is 50 micrometers. And this is a carbon fiber made by human. This is 10 micrometer. Now let us go even still smaller. Considering RBC, which is red blood cell, even micrometer is very big. So I divide a micrometer into 1000 parts again. Then you get nanometer. Nanometer is very small. What is nanometer? I take a meter, cut it into 1000 parts. I get 1 millimeter. Then I take 1 millimeter, cut it into 1000 parts. I get 1 micrometer. Take 1 micrometer, cut it into 1000 parts, I get 1 nanometer. So this RBC is 7000 nanometer wide. Our nail grows 1 nanometer per second. Every second, our nail grows by 1 nanometer. Human hair was originally 50 micrometer or 50,000 nanometers. This is how, when we move on to the smaller and smaller and smaller objects, we use meter to describe them, the size of those small items. But let us go other side. I want to measure the bigger items. This is Burj Khalifa. This is world's tallest building today in Dubai. This is approximately 850 meters high. So you can define the height of this building in terms of meter. But in the case of distance between our Earth and the Moon, this is 3,84,400 kilometers. It is very big. But still, you can define it with the help of kilometers. But the problem now happens when you measure the distance between Earth and the Sun, it is 147 million kilometers. So when the number becomes so big, the kilometer is so small, you cannot define. You need a new unit. So scientists call the distance between, average distance between Sun and the Earth as AU, 1 astronomical unit. This is called one distance, that is 1 AU. So whatever we measure within the solar system, we will say in terms of AUs. 1 astronomical unit means the distance between Sun and the Earth. But the problem is, when you go to galaxy scale, your Sun is not even a dot. Then your even AU, you require billions of AUs, astronomical units. So we use something called light years. The light year is something when the light, light is a wave. So light is the fastest moving wave in the universe. Nothing else can travel faster than the light. So the light can travel 97 trillion kilometers during 1 year. So when the light travels for 1 year, it travels 97 trillion kilometers, close to. That distance we call 1 light year. So this distance we call, this may look like time, but the meaning of this is, in 1 year time, the distance to which the light travels is called 1 light year. So our Milky Way galaxy is 1 lakh light year across. That means the light takes 1 lakh year to travel from this end to that end. So like this, we have different ways of measuring smallest unit of the Earth and largest unit in the universe, but still there are bigger distances, but we have nothing else other than measuring it in light years. So you can understand from this table that meter is a standard way of measuring the distance, 1 meter. But if you want to make it smaller, you have different names. Divide meter into 10 parts, that is 100 centimeters is called decimeter. Then you divide meter into 100 parts, then you get centimeter. Then you divide it by 1000 parts, you get millimeter. Then divide the millimeter by 1000 parts, you get micrometer. Then divide the micrometer by 1000 parts, you get nanometer. Divide even the nanometer by 1000 parts, you get picometer. And you divide picometer by 1000, you get femtometer. So here you can see it is divided by 1000. 10 power minus 3 stands for divided by 1000. 10 power minus 6 stands for, this is again divided by 1000. 10 power minus 9 stands for, this is again divided by 1000. 12 stands for again divided by 1000. 15 stands for again divided by 1000. In the case of higher, it is 1000 times of a meter is 1 kilometer. Then megameter, gigameter, terameter. We don't use it, but anyway, for in SI unit, this is the definition of higher values than meters. Having studied about distance and how we quantify it, let's move on to the next concept. Take your school bus as an example. The bus moves from one place to another place. The idea is called motion or displacement. Suppose the bus starts from one position and reaches another position. If it takes 3 seconds to travel 3 meters, 3 meters, time taken equal to 3 seconds. So we can define this as the bus takes 3 meter to move 3 seconds, or you can say 3/3 meter per second. 3/3 you can say 1 meter per second. This is called speed of the bus. So when the bus moves from one place to another place, if the bus takes 3 seconds to move 3 meters, you can call it as the speed of the bus as 1 meter per second. The bus has moved at the speed of 1 meter per second. Now let's consider there are two buses. Each bus takes different time to reach from starting to end. So the distance is still 3 meters, but this bus takes 5 seconds to travel. This bus takes 3 seconds to travel. You know, the speed of this bus is 1 meter per second because 3 meters it travels in 3 seconds. Now let's consider this bus also. This travels 5 seconds it takes for 3 meters. So 3 meters per 5 second. You can say 3/5 meter per second. We use S for second, not SEC. So 3/5. 3/5 you can say it is 0.6 meter per second is the speed of the bus. So you can say this bus is slower, this bus is faster. Because speed of this bus is more, speed of this bus is less. You can look the speed again. It is slower, this is slower, and this is faster. We have seen just moving front and back. Now suppose I want your bus is here. I want the bus to be traveling here to this place. Now there is no way it can go straight. So now there is another concept coming, left and right, left and right. So to travel this bus from this place to this place, it has to take right, travel straight, take left, travel straight, take left, travel straight. The bus comes here. So now there is a new concept called left and right. So on the surface, the world is a two-dimensional world where you have x-axis and y. This is x-axis and this is y-axis. That means this is front and back direction and this is left and right direction. Minus x, you can say it is minus y. So this is a two-dimensional plane. Whenever you travel in two-dimensional plane, you can travel from any point to any point. Suppose I want to travel from this point to that point, you can travel x-axis this way and y-axis. I'll reach this point. Or you can travel y-axis, x-axis, y-axis, x-axis. Or you can say x-axis, y-axis till the end, x-axis again. You can travel any way you want, but you can define the distances in the form of x-axis or y-axis. Now there is an interesting concept. Suppose I have to travel from this point to this point. Can't I travel this way? As this is, I have road only this towards this way. If I don't have any roads, where it's empty farm or empty ground, I can travel anywhere to anywhere. I don't have to travel this way to this way, and I can travel this way also. But even if I travel this way from this point to this point, I can define as you have traveled so much of distance in x-axis and so much of distance in y-axis. If I want to inform someone how to travel from this point to this point, I have to tell him move 2 blocks in x-axis and 1 block in y-axis. So 2 blocks he has to travel in x-axis, 1 block in y-axis. So he will go here. So anywhere to anywhere, even if you travel in any of the shortest distance, that can be defined in terms of x-axis and y-axis. For example, look at this ball. This ball is traveling from this space to this space. I can say move 5 meter in x-axis and 3 meter in y-axis. So what will happen? Someone may travel 5 meter in x-axis, 3 meter in y-axis. I'll go there. Someone may take 3 meter in y-axis, 5 meter in x-axis. I will go there. So any position in empty space can be defined as x-axis distance and y-axis distance. Here it will be a little different. Here in x-axis 3, y-axis it can be 5. This is called coordinate geometry, where This is a coordinate, x-axis is a coordinate, x coordinate, y-axis is a coordinate, y. So you define the position of any object in terms of distance in x-axis, distance in y-axis from 0, from origin. This is called coordinate geometry. Having studied about front and back, left and right, we have missed one more direction, which is up and down. So we can also, we are living in a three-dimensional world. That means I can move front and back, I can go left and right, also I can go up. So up and down. This is a third dimension. This is called z-axis. Some objects can move in all three axes. For example, take an aeroplane. This can move front and move up at the same time. After taking up, it can still move front, it can move up, also it can take left. So this is an example where real world objects can move in all three dimensions at the same time. But the interesting factor is it may move front and up, but it cannot move front and back at the same time. It cannot go up and down at the same time. It cannot go left and right at the same time. It can go one direction in one dimension at a time. Any object for that matter. This is a robot you can see, which is capable of moving in all x, y, and z axes. You can see the up and down motion belongs to z axis, and right and left belongs to y axis or x axis, any axis that we can assume, and front and back belongs to another axis. So this is called three-axis Cartesian gantry. Here one more interesting thing, you can see how rotation is converted into up and down or linear motion. A screw is rotating, and when it is rotating in different directions, the arm or the object is going up and down and left and right. Now we are going to see another interesting concept called oscillation. We have seen only about an object moving from one point to another point. Let's see what happens here. It is moving, but it is coming back to the same place again. It is moving, it is coming back to the same place again. This kind of motion is called oscillation. It moves straight up and straight front and back, but it repeats itself. Oscillation, there are different parameters for oscillation. Look at these two buses. Something is moving faster, something is moving slower. But still both are oscillation, but you need something to define this. To say that this is oscillating faster and this is oscillating slower. So we have something called frequency. Frequency is the number of times an object moves front and back in given time. For example, this goes front and back 3 times in 1 second, 3 times in 1 second. So the frequency is 3 times per second. Suppose this is slow, this may take 5 times in, sorry, this may go just 2 times a second. So the frequency is 2 because it is slower. So it takes 2 times, only 2 times in 1 second, but this goes 3 times in 1 second. So this frequency is 3, frequency is 2, but still both are called oscillations. Now, having studied about linear displacement moving, we'll see one more interesting case. There is a chair. We are looking from the top. Let's see what happens to this chair. Now, something happened to this chair. The chair did not move in x-axis, no. The chair did not move in y-axis, no. The chair did not go up and down also, no. Z-axis also, no. But something happened to this. The chair has not moved, but it has moved. So what happened to this? This is called rotation. There is one more interesting motion is called rotation. So rotation, you can just have a look at this from the top and you can see this wheel is rotating that you are looking from the side. So there are different types of rotations, like how do we found the different types in motion like x-axis, y-axis and z-axis. The rotation also having 3 different types. You can have a look at it. Look at this. This is rotating with respect to x-axis. That means this is looking like a shaft, and this is inserted. So it is rotating clockwise and anti-clockwise in with respect to x-axis. So this is called x-axis rotation. Now look at this. This is rotating with respect to y-axis. It is looking like the y-axis is the shaft and disk is rotating with respect to y-axis. This is called y-axis rotation. So you must know now this is z-axis. So this must rotate with respect to z-axis. Clockwise and anti-clockwise. So the rotation, there are different types of rotations, like similar to linear displacements. Now let us see another case. There is a ball. This is some distance in x-axis, some distance in y-axis. If it moves, the distance in x-axis reduced, the distance in y-axis increased. Again, the distance in x-axis reduced so much, distance in y-axis increased. The distance in x-axis reversed, that means it became negative, the y-axis has come down. So this is minus x, this is x, this is y, this is minus y. Now I'll do something, just you can observe this now. What happens to this ball? This is moving in x-axis and y-axis at the same time. But it looks like rotation to us. But actually it is moving only in x-axis and y-axis at the same time. You can have a look at the same thing with the wheel. So in the case of wheel, if you consider a point, this point, if this is x-axis and this is y-axis, this point moves this way. That means it is coming down in x-axis, coming down also in y-axis at the same time. So if the ball has come here, that means the x-axis distance reduced and the y-axis distance increased in negative side. So the rotation also may look like rotation, but it is actually the combination of displacement in x-axis and y-axis only. Now, as similar to oscillation in linear, you can see rotation also can have oscillations. It can rotate front and back in a particular frequency. It can rotate faster front and back. It can rotate slower front and back. This is called oscillation in rotation or rotating oscillation. We have to see another concept in rotation. Just look at the disk. The disk is rotating with respect to its center, clockwise or anti-clockwise. So the disk is moving with respect to x-axis and y-axis as the center. So this is also a type of rotation. But let us see another interesting concept. Suppose there is an arm for this disk, and that arm you don't see, it's an invisible arm. Let us see what happens if you rotate with respect to this center. This has x and y-axis. So as I told you, this is x-axis and y-axis. So suppose this rotates like this. So if it is an invisible object, though this disk is rotating this way, but it is rotating with respect to another center, not the same center. This can oscillate also in the same way. You can have a look at it. This is also rotating oscillation. It is not necessary that rotation or rotating oscillation has to be only at the center. It can have different center also. This way, you can understand how real world motion happens in the universe. How is it defined for various engineering applications and physical world applications.